Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to talk about the dipole and its radiation pattern and how it works with the ionosphere and things like that, okay? Our question is from Edwin Anderson. Okay, he's studying for his technician. And his question is this: thank you for the shared knowledge available on your channel. Thank you very much. If I use a dipole for ionospheric propagation, okay, we're talking HF right here. What is the proper orientation and antenna angle relative to some specific distance receiver? Is it just any orientation and parallel to the ground? Yeah, actually pretty much. Or a specific orientation and antenna angle preferred? The answer is kind of yes, but not that much so. Let me back out a little bit here. And we're going to draw a dipole. Okay, a dipole is a half wavelength long. Now, that's lambda, which is the Greek letter that we use to refer to wavelength, over 2. If this is a 40-meter antenna, which is 7.000 to 7.300 megahertz, this works out to lambda equals approximately 132 feet. Now, I apologize for going into imperial units, but that's what's in wide use in the United States. Now, I'm fully aware that a quarter of my audience is outside the United States and therefore using metric, since the United States is the only holdout anymore on the imperial system. But 132 feet, you buy wire by the foot, you measure it most easily by the foot, and so on. So lambda over 2 equals 66 feet. And that's going to be the length of the dipole. Now, I would put in some masts here. This mast can be made of aluminum fence top rail, which you can buy pretty cheaply, 20 bucks or so a piece, at Home Depot, and the parts just fit into each other. I would not go 3 high, it's too wobbly. 2 high, and then put guy wires down for the thing. And a piece of rope about 3 feet on each end. By the way, if you have extra wire and you fold it back on itself like that, that does not count as extending the wire. That is the end of the wire right there. And that is the same whether it is insulated wire or non-insulated wire. You can get wire. I use 12 gauge THHN stranded insulated wire from Home Depot. You can get it on the reel. You can get like 500 feet of just a single piece of wire. You don't need to buy Romex and split it apart. You can just get the single piece of wire. Now, you'll get like 250 feet, which means you can put up a lot of antennas with that thing. 250 feet or 500 feet. Every ham is always changing his antenna. So now you're going to break it in the middle and put an insulator in here. You can get electric fence insulators, insulators specially built for antennas that are made of ceramic that you can get from MFJ. Lots of places to get this. Or just a short piece of PVC pipe with holes drilled in it. Bring the wire through that. Then you bring your coax here. The inside of the coax goes to one, the outside or shield goes to the other, and that is soldered right there. Now, purists will tell you you should have a ballon there. I've had bad luck with ballons there, and so I don't use them, and it seems to work just fine for me. But anyway, this piece of coax has got to go all the way to your lightning arrestor or whatever. I will tell you that no matter how carefully you calculate how long this piece of coax needs to be, it's going to be too short. So I'd go ahead and buy a 100-foot coax, and if you have extra, just coil it up on the ground. Okay, so that's a dipole. Now let's look at radiation patterns of dipoles. If you look at the top, this is top down. A dipole, of course, is horizontal with the ground. I'm going to put it vertically right here, okay? We're looking down on it. The radiation pattern of a real dipole looks about like that. And the closer to the ground, or the more like an inverted V it is, the rounder this is. So in free space, of course there's no such thing as free space on Earth, all right? Except maybe from an airplane or something. In free space, you will have very sharp nulls. In actual practice, you will not. So you'll be rating mostly off the side, but you'll also be rating some off the ends. By the way, the propagation out here is horizontal, but at the end it gets weird. This propagation over here is vertical, as it switches over now to being horizontal on the other side. Now, once the propagation hits the ionosphere, it's going to get broken into two pieces. I'll show you how that works. But first, I want to just point out something about antennas. If you look at an antenna down here, the radiation pattern, if this is 1/2 wavelength, is like this off each end, and then it's that on the other side. If you take the 3 dB points, which is considered the beam width of the antenna is radiating in lots of different directions, okay? It's not just radiating in one direction, it's radiating in lots of directions. By the way, if you bring your antenna down so it's closer to the ground, like lambda over 4, the radiation pattern will be higher. Okay, until you get it down to the point where the radiation pattern is pretty much straight up at about lambda over 10. So this is why we want height. But now what happens if you put an antenna above a half-wavelength above the ground? Here's what happens. Let's suppose we go for 1 wavelength above the ground. Your radiation pattern is going to look like this. It's going to be lobed, and it will have a sharp null at those points, okay? I don't consider that an ideal radiation pattern. But that's what happens if you put an antenna above a half wavelength above the ground. Does it lens like that on 2 meters? Absolutely it does. That's why you may, have to tweak your antenna, move it up and down a little bit on 2 meters. Now let's look at the ionosphere. The ionosphere is a plasma, gas plasma, 75 to 300 miles above the Earth, and it varies from day to night. Okay, so you're down here. Now your antenna is generally emitting horizontal radiation, but it's linear polarization. It's polarized in only one direction, regardless of where it comes off the antenna. When it comes up and hits the ionosphere, remember that you've got this lobe right here. So your signal is also coming up here, also coming up here, and so on. And each one of these is going to give a kind of a weird directional pattern depending on the lumpiness of the ionosphere. Now, it does other things. While these are linear polarized, these are circular. And there's something called the ordinary ray, and so the other part is called the extraordinary ray, and it comes off at a slightly different angle. So if this is the extraordinary wave, and this is the ordinary wave, they are circularly polarized in opposite directions. What I'm trying to tell you is that ionospheric transfer is more complicated than you might see it made out in the technician and general class books. But if you, now this area right here, from here to here, it's called the skip zone. Because nothing will be heard in here. And then you get out here where you actually get ionospheric propagation. This can be on 40 meters in the daytime, be about 200 miles. Okay, sorry again for the imperial units. 25% of my viewers are outside the United States, so they would really prefer I did metric, but in the U.S., people don't have a good metric intuition. So that's why we do this like this. So let's see if we've answered your question. If I use a dipole for ionospheric propagation, what is the proper orientation? Horizontal. And antenna angle relative to some distant receiver. Well, as I showed earlier, dipoles, real dipoles over real ground, are a lot more unidirectional, not unidirectional, omnidirectional than other antennas like beams and so forth. So you put up your dipole and it will work. Generally, if you put a dipole north-south, it will mostly work east-west, but it will still also work north and south. Now, where I am in the middle of the United States, I try to put the dipole sort of north-south, but it depends on where I have room on my lot. By the way, this stuff all goes for this side over here, too. And yes, I'm going to answer another question I know you've got. If I've got ionospheric propagation over the Earth, yes, you can get more than one hop. Okay? And you can go very long distances. The furthest I have spoken on 40 meters is South Africa. Okay, that's about 12,000 air miles. That's halfway around the globe from where we are. So, yes, this can work very well. So, Edwin, I hope that answers your question. Now, if you've watched this far, I would like to encourage you to subscribe to this channel. Subscribing is your vote of confidence to YouTube that you think this is a channel they ought to share with other people. And I hope you feel that way. Also, please like and subscribe. And also, if you would like to support this channel financially, you may do so by going to dcasler.com/support. And there are several ways listed there, like Patreon and so on. So until we next meet, 73.